Hello there. Check out this new gadget I made. I call it power delivery, power supply. Because, as the name implies, power to this power supply is delivered via power delivery. Here's the USB-C connector. Functionally, it is quite simple. On and off switch, a button that cycles requested voltages from the power brick, an RGB LED that indicates set voltages, banana connectors, and this famous buck converter model from AliExpress. I believe it is called DPS 5005. And on the inside, I have this power delivery trigger board ZY12 PDN. Nothing fancy. Now let's see it in action. And to power this thing, I'll use this 65 watts wall adapter. Let's plug it in. And it doesn't work. That's right. I forgot to turn this thing on. As you can see, it is online now, but it won't actually work. You see, I turn it on. It won't even turn on. Or it will turn off automatically. Because 5 volts is not enough for this module. This LED now shows that trigger board is asking for 5 volts. In order to cycle those voltages, we will use this button. Now it's yellow 9 volts, green 12 volts, cyan 15 volts, and dark blue 20 volts. And yeah, it works fine. Maximum possible voltage is 19 volts, I believe, because it can deliver all those 20 volts that it requests. Let's burn something, shall we? I will burn this 50 ohm resistor, and let me get my wires. And 3, 2, 1, fire in the hole. Oh yeah, it's barbecue time. Oh, the smell is always amazing. And we fried this thing in a matter of seconds. And it's still not the maximum possible power it can deliver. But I think it's enough to power some Arduinos. I say it is an awesome portable power supply. It doesn't replace an actual power supply, but for low voltage tasks that are not that noise sensitive, it is more than okay. Considering the fact that you can fit it into your pocket, and this wall adapter into your other pocket. And also, you can potentially use both of these with the portable soldering iron like this TS101 iron. Let's test it. I connect both of them into my wall adapter, and they will reboot a couple of times because they are trying to figure out voltages. And let's start heating the iron. Let's go for the 300C. As you can see, it is asking 12 volts, and let's trigger the power supply for 20 volts and turn it on. It is quite slow, but I think you can solder something with it if you don't have any better options. And yeah, it's working. Anyway, that's about it. If you found this video useful, please consider liking and sharing this video. Bye. A small side note, I have decided to measure ripple and noise for this power supply, and here are the results. On these pictures you see its performance under a 4-watt load, and ripple itself is 20 millivolts peak to peak, but the noise is horrendous, 80 millivolts peak to peak. On this picture you see its performance under a 60, almost 17-watt load, and the ripple is almost the same, but the spikes are even worse. And finally you see a 55-watt load. Considering the fact that the power supply is powered by the 65-watt power brick, so the ripple is almost the same, but the power spikes are even worse. I think it might be my improper measurement, because I'm using this standard alligator clip oscilloscope probe loop, and this environment is quite noisy, so yeah, I was too lazy to look for proper springs. And also I forgot to toggle 20 megahertz bandwidth limitation on my oscilloscope, so those spikes might be some high frequency noise that is caused by something else, but I don't know, I'm not sure. Tell me in the comments below.